Today we're learning to subtract polynomials. Typically you'll see it in word format, for example, when 4x squared plus 7x minus 5 is subtracted from 9x squared minus 2x plus 3. Now, typically someone who doesn't read carefully will make the mistake of doing whatever that blue first polynomial is minus whatever that second, in this case purple polynomial is. They'll just do what's listed first minus what's listed second. And when we do that, it's because we didn't read carefully. So in order to help better understand the order and why the order of it does matter in a word problem like this, here's an example, same type of wording, but notice instead of using polynomials, I'm using just regular numbers to give it a real life context. So for example, when 10 is subtracted from 20, it becomes more obvious that I'm not doing 10 minus 20 and getting a negative value in money. Instead, the correct order is 20 minus 10. This is the correct order, although 20 is not listed first in the problem, 10 is. The word from is telling me where I'm starting from. I'm starting from 20, and I am subtracting the 10. 10 is subtracted. Another word you can use to substitute is taken. When 10 is taken away from 20. So here we have 10 taken away from 20. Another way to think about it is, again, from is where I'm starting. Like I am from, the country of Peru, which means if I were to do a word problem, this would come first. So back to the polynomial, the wording being the same is telling us that I am starting from the polynomial 9x squared minus 2x plus 3. And what I am subtracting is 4x squared, the whole thing, the whole polynomial, 4x squared plus 7x minus 5 is subtracted. So here's my setup. Now sometimes the problem's already set up for you, so you don't have to do the setup. But a word problem like this, or the math is embedded in the English language, then we set it up. And we want to set up in the correct order, otherwise you get the completely opposite answer. So like in the other video, adding polynomials, I'm going to go in, and if I don't see an exponent, I'm going to put the invisible exponent of 1. Okay? So there are a couple of ways to do this, but the way that we do it in our class is by converting this subtraction problem into an addition problem. Now that may seem weird, but think about it. Let's just again look at numbers. I know that 7 minus 9 is the same thing as 7 plus negative 9. And if you don't believe me, take out a calculator and you'll see they both give you the same answer. I'm basically distributing that negative to the 9. So the negative was distributed to the 9. Negative 1 times 9 give me negative 9. And I have converted the problem into an addition problem. So that's what we do here for step 1. S1 for step 1. Now just like when we converted 7 minus 9 to be the same as 7 plus negative 9, the first number that you're starting with doesn't change. So the polynomial that is written down first doesn't change. And then I'm going to convert the problem into an addition problem. And I'm going to distribute that invisible -1. It's negative because we are dealing with a subtraction problem, -1. So there's actually an invisible -1 in front of this second polynomial. Let me do the arrows underneath. And when we have the distributive property, that means that that number outside the parentheses, there's an invisible multiplication and it's being distributed to all the terms. So I'm not only multiplying the -1 to the 4x squared, but I'm also multiplying it to the 7x, and I'm also multiplying it to the -5. And when you multiply a number by a -1, it causes the sign of the original number to change. So multiplying -1 to a +7, that +7, and I know it's a positive because there's no sign, becomes a -7. Similarly, if I multiply -1 to a -8, for example, the -8 is now a +8. So by multiplying or distributing the -1, you're flipping the sign of the number that you're multiplying to the -1. So a +7 becomes a -7, for example, and -8 becomes a +8. So in the same sense, we apply that here. That is a +4x squared, because I don't see a sign in front of the fourth. +4 becomes a -4x squared. -1 times +7x to the first power, +7 times -1 becomes a -7x to the first power. -1 times -5 gives me a positive. So the signs flipped. Invisible plus sign became negative here. So now that I've converted this problem into an addition problem, step 2 is just like step 1 for adding polynomials. So now I can go ahead and line up both polynomials vertically by like terms. So I have 9x squared minus 7x1. Notice the x to the first term is not missing, so it comes after the x to the second term and then the constant. So that's this guy here. And now I'm going to take the second polynomial and bring it down underneath the other one. The 5 goes underneath the number. The -7x to the first power goes underneath the -2x to the first power. Like terms, same variable, same exponent. And then the -x squared goes underneath that. Now be very careful. Sometimes students get really sloppy and then they make the exponent all huge like that, and then it completely changes what you're seeing. It's no longer 2x's being multiplied to itself. So the exponent has to be a little number at the top. We call it a superscript. So now I'm going to add down, because we've converted into addition problem in step 1. So I'm going to add 9 plus -4 gives me positive x squares. Then I'm going to add -2 plus -7. And I'm going to add those down so I can find out how many x to the first powers I have left. So it's going to give me -9. I put those two numbers in the calculator and add them, and then we have a +8. And then again, in the regions in a multiple choice, you're not going to see the invisible first power. Let's do another one. Okay. Again, this is very typical format to throw people off in terms of the order of subtraction, so we're going to leave that. It says when 3a to the second power, so now we're dealing with the variable a, minus 2a plus 5 is subtracted from a squared plus a minus 1. So we're going to move on to the setup. I'm starting from a squared plus a minus 1. So that's going to be the first polynomial. And I'm subtracting 3a squared minus 2a plus 5 is subtracted from this. And before I move on, I'm going to go and put in the invisible coefficient when we don't see one. Another one here. And we're going to put in the invisible exponents when we don't see one. And then this negative is actually a -1, the invisible one. Now someone in school asked me, what about the number in front of the first polynomial? If you don't see a number in front, what number is being multiplied to this polynomial? It's 1. But if I were to multiply any of these numbers by 1, positive 1, nothing happens because 1 is the multiplicative identity. You can multiply any number by 1 and it doesn't change the number. 1 times 1 is still 1. 1 times 1 is still 1. 1 times -1 is still -1. Hence why the first polynomial, if you don't see a number in front, then it doesn't change anything because it's a 1 being multiplied to the whole number represented by this polynomial. But in this case, when we're subtracting that second polynomial, then by distributing the -1 out into all the terms inside the second polynomial, we have turned it into an addition problem. So it's really important that we don't forget that piece. So let's go ahead, starting with the problem itself, the problem's main operation, turn it into an addition problem. Then we can go ahead and distribute that -1. -1 times 3a squared, positive 3 becomes a -3. -1 times -2a, and -2a becomes a positive 2a. -1 times positive 5, a positive 5 becomes a -5. Notice distribution is multiplication. Not once did I add any of these coefficients or constants to the -1. I always multiplied it. So the only difference you're seeing in that second polynomial versus the setup is that the signs have flipped. So once we are there, we can go ahead and move on to step 2, which is just like step 1 when we're adding polynomials. And it makes sense why they look the same, because we have turned this into an addition problem in step 1 by distributing out the -1. And then we're going to bring the second polynomial and we're going to put it underneath the first polynomial under the correct like term column. And then we can add down. We have -1 plus -5 is -6. We have positive 1 plus positive 2. That gives us 3a to the first power. And then to figure out how many a squares I have -1 plus -3. It's going to give me -2. Now notice sometimes kids forget that forget to bring down the sign. If you are adding a positive and a positive, it's going to give you a positive number, so you have to have the sign in front. Plus 3 because we're dealing with a positive number. If that 3 were in the front, like here in the problem, like here, then when it's the first positive number, that's when we don't put in a positive sign. We just assume that first number, if it doesn't have a sign, it's a positive number. But then any number that comes after that, if it's a positive 5, we want to make sure we have plus 5 there. And again, if I'm going to see this in the regions, it's not going to have the invisible one over there. Feel free to stop this and go back and watch it as many times as possible. Now, like I said, this format, word problem, is very popular. Sometimes you'll see it like this. If A equals this and B equals that, find A minus B. This is telling me the minus sign, I'm subtracting. I'm subtracting whatever A is equal to minus whatever B is equal to, because it said A minus B. So whatever A is equal to would go in the first polynomial. Whatever B is equal to in this case will go in the second polynomial. So that's another way that you could see the same problem or a similar problem. Now and 15 minutes into this you can stop if you're ready for a challenge. Then let's take a look at this one real quick. This is a problem already set up for you, but we can tell that, okay, we are subtracting two polynomials because of the sign. Now it's already set up, so I can go straight to step 1 where I am distributing. But now the -1 is not the only number that I am distributing. We're also going to distribute the 2. Now, I don't know why some students will do something like this and start distributing that number elsewhere. Notice that the 2 is right in front of this first polynomial, right in front of this first set of parentheses, and there's the invisible multiplication. So the only numbers that 2 is going to distribute into is to all of the terms inside the parentheses that it is right next to. So that 2 is going to be distributed to the 3g and the -4, and that's it, because those are the only two terms in the parentheses right next to the 2. So since we are dealing, let's go ahead and distribute the second one. -1 gets distributed, so we're turning the problem to positive. And then a -1 times positive 8g, it's a positive 8. We just don't put the sign when we're dealing with, when we're writing the first positive number in an expression, but it's there, it's just invisible. A positive 8 becomes a -8g, and a positive 3 becomes a -3. And now we distribute the 2. So the 2 in front of the parentheses does change that part. So 2 times 3 is 6, but we're dealing with groups of g's, 3 g's. 2 times 3 groups of g is 6 groups of g's. 2 times -4 is -8. So that's the only difference here. It's just step 1, you're distributing 2 numbers to clean it up a little bit. And now we can go to step 2, where we line them up by like terms. 6g to the first power. Remember, there's an invisible 1 there for an exponent. And then we take the second polynomial and then line it up underneath the first polynomial. And then we can add down. -8 plus -3 is going to give me -11. And then let's see how many g's to the first powers we get. 6 plus -8 is -2 g's. And then in a multiple choice, that's going to, the invisible one's not going to be there. That's it. Take care, everybody.